Hello, everyone. What a fantastic day it's been so far. So, seeing as I'm closing up in Odin, I just want to take this opportunity to thank all of the organizers and give them a big round of applause. So, if you guys can help me out with that, that would be terrific. I know that my description for the talk is a bit could be misleading to some. So if you're not an iOS developer, there are stuff in here that can apply to any platform. But there are code examples, but I'm keeping them on the download, but they're in there. So let's get the show on the road. So why are we here? Why are you listening to me? Well, first of all, I'm not here to sell a framework, that's for sure. But I am here to share what we learned by building a framework. So naturally, you have a first step. You start by being inspired. And then you collect some underpants. Probably have seen this joke before. And it equals profit. You return a profit, and then you're done. But I want to focus on the in-between, like how did we get there? So, so who am I? I'm Chris. I work as an iOS developer at Hyper. I started doing Mac development when it was still called OS 10. And people were still arguing about if automatic reference counting was a good idea or not. And just saying that sentence out loud makes me feel a bit old. So Hyper, as a company, has invested a lot of time and effort in doing open source, both using it and contributing back. And it's kind of a part of our business model because we've worked actively with our customers to have them on board with those kind of decisions. And they've really come around and understood the benefits of doing it that way. I guess we're better known for Hyper Oslo. That's our GitHub account. And we're really most famous for our Swift contributions when it comes to doing frameworks. So when we go to conferences, people come up to us and ask like, "Oh, you're that company that made this one image library called Image Picker." We made a whole bunch of other things, but that's one of them. And doing open source it's a lot of hard work. And I think that everyone who started doing open source has pretty much had the same feeling that I had when I started at Hyper. Because when I started, I hadn't really done any code out in the open. But there was already like an established culture around doing open source and why it's important to actually give back. Like if you're going to use something, you should also contribute back. And so it was kind of daunting at first, but I was thoroughly convinced, and the way that we did it sort of, I found a bit of comfort in just the process that we had around it. So when I started, it was actually the Rubyists at Hyper that were the real rock stars of doing open source. They truly embraced the culture and the mentality. And looking at it from the outside, being a part of a different team, it really felt like it was second nature to them to do it. And who doesn't want to be a rock star? So naturally we wanted in, and we had three fundamental things that we wanted to achieve when going the open source way, and that is like the main benefits that we saw is like code encapsulation, code modularity, and code reuse. And just having this encapsulation really helped us in times where Swift had this huge compiler time issues. So just taking the code and running it in isolation really helped to speed up the development. So we used to extract code. That's basically how we got started, small bits and pieces, small utilities and so on. And now we actually build them as open source from the get-go. And when doing that, it really helps you sharpen up, and it cuts out any strong ties that you might have to the application that you build it to. So I think it's still a great way to like extract bits and pieces that you see value in, but I would definitely move in a direction where when you start without any ties to the thing that you're building. And it takes a lot of work, and you kind of have to change your process in order to make it work. And what I've seen for myself is if I see like the enjoyment that I get out of building either an app or a framework, I kind of feel that building frameworks, at least for me, and this is my personal opinion, I find that more gratifying. So I have this small, like, if an app was a superhero, then the frameworks would be the superpowers, which makes it sort of exciting. But when it comes to like adding frameworks, of course, there's with great power comes great responsibility. So you should really think about those choices that you make and the kind of dependencies that you add to your project. Before we go any further, I would like a small intermission just to give some praise, because being nice is nice, and I feel that this is you should really give credit where credit is due. So the iOS team and Hyper wouldn't really be where we are today without Elvis Nunes. I would actually go as far as to call him the grandfather of Hyper iOS. He hired me, which kind of makes him one of the crazy ones. He was crazy enough to do that. So he was the one who really wanted to go into this space and really saw the benefit, and also convinced me that this was a good idea, even though I was terrified at the time. The next person is Ramon Gilbert. He's the main developer of the image picker, our most famous library, and he really broke new grounds again and again with his incredible attention to detail, and he still remains an inspiration to the team this day. Unfortunately, they don't work for Hyper anymore, but they do deserve all the credit that I am capable of giving them. So again, if you can just join me in giving them a round of applause. I know that Ramon is not here, but Elvis is over there. So let's try and make him blush, okay? So, to continue. Whoops. We went to Krakow in 2015 to a conference. It was before Mobile Era. Otherwise, we would come here, of course, to MobiConf. And there were really two talks that stood out for me. And that was Ash Furrow talking about the evolution of asynchronous programming. And it wasn't really the talk in itself, but he brought up a really good point in that talk. And that is looking back at old code. So he talked about this developer context that you overlook that certain choices were made at the time when the code was made, and they certainly made sense at the time. But as you go along, like there might be changes in the language. It might be constraints that you don't really document, and you can make poor decisions, but they make sense because you have time constraints or whatnot. And then, of course, there was John Sundell, who presented how they platformized their UI at Spotify, and that's what really sparked us wanting to change the way we work to some degree. So basically the talk was about like how do you turn JSON directly into UI that you can use. So when starting out building new frameworks, it's always nice to have rules, requirements, and some form of constraints so that you don't try to make the Swiss Army knife that's going to be applied in every case, because there are no silver bullets. Think about it as a North Star. Where is this framework heading? We didn't have those. We didn't really spend that much time of doing like the paperwork of things. Instead, we sort of had a look at all the projects that we were currently building and looked at common denominators. What are our pain points when it comes to building UI, and how can we iterate faster by having a framework help us out? So it came down to 3 types of UI, which is basically you can have a carousel that's something that scrolls horizontally. You can have a grid that's showing more than one item per row, and you can have a list. You've all seen those in an app. But here comes the first thing that I had to tackle, and that was my really bad relationship with UI collection view at the time. It all boils down to that I didn't really understand how it actually worked. So this was, of course, holding me back because if we wanted this flexibility, it kind of felt that it would be a good idea to base the framework on a UI collection view. So when we had discussions at the office, I was pretty much always in the corner that said, okay, well, let's not use a collection view. Why? Well, there are other alternatives. That was pretty much my my only reasoning behind not picking that one. But this is something that that I overcame. So I went to a bit of collection view therapy and really looked at what the implementation is like. Next up is some faults that we made along the way. So when it comes to naming, and of course naming is among the most hardest things to do as a programmer. And the framework that we built, we wanted to give homage to the company that actually came up with the idea in the first place. So we thought that spots would be a terrific name for it, because spots can come in all shapes and sizes. You can organize them. They can be utter chaos. But it's also a play on words with Spotify as a company. But we took it to an extreme where we started introducing this this thing into the framework. So instead of calling something like a component, instead we call them a spot. So you could have a list spot, you could have a carousel spot, you could have a grid spot. And of course, when it's going to conform to stuff, we wanted a common protocol for all of them, so we called them spottable. And we didn't call the model for a model, that was the actual component. So it became very hard to discuss things because you always had to look up in like our own little dictionary what we were actually referring to. So name stuff for what they really are. Like a model is a model, a component, it's still abstract enough, but it can be expressed as in, okay, a component equals a UI element, for example. And we've done our spring cleaning on that. Whoops. And we also pretty much jump on the Swift bandwagon, and we started adding protocol extensions like to the bone. Like pretty much everything that a class had was added with protocol extensions. And we started using compiler features, it's basically my next slide, to add support for multiple platforms, which well, what we used was conditional build directives. So basically, which platform would do different things, but they are not really intended for people to read when it comes to like reasoning about code. Mainly because the compiler is very good at opting out, but when you read something from top to bottom, it's kind of hard to know exactly where stuff is going to end up. And then it comes down to, like, we wanted to support all of Apple's platforms. So again, the things that we were using actually had a very nice use case too. So if you combine conditional build directives with type aliases and with protocol extensions, you can really support multiple platforms in a really easy way. So one thing that we did, because in macOS you don't have the concept of any UI elements as in the prefix UI. Everything is still back on NS, pretty much. So we made our own type aliases. So whenever we reference a view in our framework, we use the type aliases view, which is going to point to different things depending on which platform you're on. And when it comes to some, like, it's a bit skewed. So in macOS, let's say that you want to force a view to layout. In one of the platforms, you have to set a flag to true, and the other one you call a method. So basically, you could add these so that your shared code actually invoke the method that you want. And what we saw with our like framework-based way of building things is that it led to a lot of ownership when it came to building applications at Hyper, because we found ourselves being pseudo co-workers, even though we weren't actively working on the same applications. But if you add the functionality into a framework, you could pretty much smash two flies with one stone. Birds. Anyways, but it also led to some friction within the team, because life happens, and being able to discuss and have this ownership and to really share the direction of where we're heading became hard, because we got deadlines, we had meetings, and eventually people started feeling they felt left out just because they weren't there when we had these discussions. Like, when was this decision made? This is going to affect me in a way that's negative, or I have a different opinion. So we sort of were caught in a spiral, and we saw that we had this decline in collaboration just because my own priorities like outweighed any other. Like the willingness of collaboration sort of cut down just because I had other priorities. So we needed to address this, and fast. And I mean, there are many ways to skin a cat, but we ended up doing this. So to fight Slack, oral communication, and those kind of things, we wanted to have discussions in one place. So we created an open source repository where we added discussions, and we wanted to share these findings with anyone, and we don't really discuss anything that's a company secret, so why not make it out in the open? So the benefit of having something that is, I would say, like synchronous, so I can go in here and read any time that I want, instead of having to always be a part of every discussion that's going on. That has really, it didn't really solve the problem per se, but it helped a lot. We still have these regular discussions at the office where everyone can't attend, but we don't take action before we actually make an issue and discuss it with everyone. So when it comes to what we actually added to the framework, or in this case, our key features, or if you want to translate that differently, like what were the pain points that we wanted to solve. So why and how is important. And I'm also going to show you some small code examples extracted from some applications that we've been working on, just to show you why these things are important. So the features that I wanna show you is basically reload only if needed, declarative UI, and state cache. So when it comes to the first one, the reload if needed method, so why did we actually need this in the first place? So basically, this is something that we saw we were doing over and over again in our applications. Like we started diffing the actual view towards the model, and we got some bug reports that were super silly, like my app blinks. And of course, we didn't want to always implement our own diffing method for all our applications, even though, because we saw that we couldn't find like a feasible solution, so we wanted to offload the app and have the framework handle that for you. So basically this is possible because we have a shared model, which means that we can do hard and soft updates. So if we're switching out an entire view, we know, for example, that we need to make a hard update, which would actually invoke if it's a UI table view, it's going to reload that specific view. Otherwise, we could just aggregate new data to the existing view that we already have. And it really helped us to pinpoint in more detail what actually changed. So to give you a sense of what this looks like in an application, we're going to I'm going to show you a small snippet. So imagine this being something that's being called in view will appear. So we have a service that we call fetch on. It returns a result type, which gives us back a success and a failure. And because we're good citizens, we want to handle the error first. And what we're expecting back is a bunch of components, or in this case, component models. And the only thing that we have to do is tell the controller to reload if needed with these components. And that's everything that we wanted it to do. So if you look at what it's like to actually work with the framework, or if you're going to build this, this is actually what you want to achieve. As little as effort as possible to get the most out of it. So it's basically just a one-liner. And then we wanted declarative UI because we saw that when doing code review, it's kind of hard to see the entire context. And we wanted, like, we are not a company that invests in either zips or storyboards or anything, because we think it's negative when it comes to code review. And doing things vanilla is definitely nice, but there's also a drawback there that you can't really look at a UI in a code review and imagine exactly what it's going to look like, because there are so many different things to look at to actually understand it. So that's basically the why. And we wanted also something that would be easy to change, or something that could respond to change very easily. So what we ended up doing is we designed a component model. Again, this was called something completely different when we started, something super silly. Can't remember the name right now. So let's make a grid, and let's give it some layout properties. So in this case, I'm making a grid, which means that I now know that I'm going to get 3 views in a row until it hits the next line. I'm going to get an item spacing of 10 and a line spacing of 10 to get some breathing room between the items. I can also add some insets at the top and the bottom. And if I do decide to add a view, In this case, we decided to call it an item. So just by looking at this, we can turn this into a UI by just calling component and giving it a model. By looking at this example, I can see that, okay, I'm adding one item. It's going to appear in the top left corner with an inset of 10 at the top. So if I were to look at this in a pull request, I can imagine what this UI would look like. So there are still magic numbers in there, but they actually describe something instead of being something that I can't really relate to. Next up is something that we decided to call state cache. And remember earlier when I said that Spotify inspired us to do this. So everything is JSON based, which opens up some fantastic opportunities for us. So why did we want this? Well, basically because we saw that we over-engineered our applications. Essentially what we use the state cache for is to not necessarily trick the user, but to give them the content that they already have. And of course there are many ways of doing caching. You can cache in the network layer, and what we did before to get like the offline behavior was to actually add realm, even though we didn't have like any mutating state that we needed to handle. So the solution that we came up with was basically, because we can turn anything into UI, like JSON from UI, and the reverse. So if I were to implement this in the method that the example that we had with reload if needed, the first thing that I need to do is give the controller a cache key. So in this case it's mobile era. And this cache key is going to be used to make an MD5 string and save it to disk. And the only thing that I need to do is to invoke the cache as soon as reload if needed is done. So combining these two features, you get a lot. We see that we got a lot of stuff for free, and of course, well. One negative bit is like if you do introduce a bug, then you're breaking a lot of apps. But if you fix a bug, it's in the reverse. So you do get a lot of the benefit. And there's one more thing that I want to show you. It's not really a feature, but it's how we solved a crucial part of the framework, because we talked, or I talked, a little bit about the different UI components. So I wanted to share how we solved doing complex UI with a scrolling experience that's buttery smooth and that still keeps the dequeuing. So if we look at this layout, we had a carousel at the top. It's pretty familiar. And then we have a grid. And then we had a list underneath. This is not a very unfamiliar layout, in my opinion. I've seen this in multiple apps. So from a framework's perspective, if we were to build models out of this, it would be a carousel at the top, and it would be a grid, and it would be a list underneath. If we translate... poop. If we translate this into actual UI elements, we see that, like I told you before, it's a UI collection view with a horizontal layout, a vertical layout, and then we have the UI table view. And to solve this thing in a good way, we wanted an outer layer that was component independent, which meant that we wanted to look for a common denominator between the two UI elements, and we landed on that both are scroll views. So what we ended up spending some time on are, so we found this really nifty solution. We didn't really come up with it. So we created a parent scroll view. So I'm just going to quickly go through the code and show you what it's actually doing. And then I'm going to tackle some controversy because I saw a tweet late last night about similar things. So we start off by having the y offset of the current subview being 0 because we want the first component to start at the very top. And then we have our subviews in a layout order, which means that if I have the component, my carousel at the top, that's where it's going to be. So it's kind of index-based in this way. It's just an array of UI scroll views. Then we create two variables that we need to mutate. So we take the scroll frame and the content offset. What? Why you do this? Fantastic. Well, something had to go wrong. Really? Maybe if I can just skip that slide, maybe there's a bug in the thing. Okay, I'll just show you it in its entirety. And so we created these, and then I start giving it the current content offset minus the y offset of the current subview. And this if statement here is basically there to imagine you're having pull to refresh, and you start scrolling to something that is below 0. Then you don't want that view to actually be connected to your current scrolling position, because that's going to cover any UI refresh control that you add. So this is basically the important part. By defining the remaining bounds height of the parent and using the frame that we declared here, and then taking the remaining content height, and that's based on the size, minus the content offset y, we can effectively create a new frame that's basically going to tell us if the view is coming in from the top, if it's reached its full potential, or if it's going off screen. So what's going to happen later down here is that when we set it back, it's going to scroll any scroll view that we put into subview in layout order. So when it scrolls past screen, it's going to deallocate all its views, and the next one is going to take over. That way, it's only going to allocate the views that are actually necessary to show. And last but not least, to get the entire content sizing correctly, we set the content size based on this value, which is basically the content size height of everything in the collection. So like I told you before, this was not our idea, so we totally stole it and bend it to what we needed it to be. So if you want to know more about how, it's Oli does a very thorough explanation of what it actually looks like. So I wanted to share one more thing with you, because this whole thing late last night after the speaker dinner, I checked out Twitter. So I saw this thing, which I thought was interesting. So basically, it's a bad idea, or is it a really, really bad idea? And I saw some interesting responses that you're gonna lose some of the redrawing stuff, basically. People have very strong opinions about this, and they come with other solutions. But this is definitely my favorite. That it would actually be that bad of a design decision. It definitely has its pros and cons, because if you never know that the user has scrolled past a certain item, you can't necessarily predict, you can't really have any strong reference to your views, which in my opinion is nice, but it kind of breaks the delegator pattern. But it's basically the same as working with any other UI table view, where you need to set delegation on a view, for example. So I'm gonna try and tackle a sort of a controversial topic that's been widely discussed, and that is, why do it natively at all? It feels like we're sort of entering Vim versus Emacs territory to some degree. People have very strong opinions that React Native is the future, cross-platform is the future. So why are we sticking with native? And I can't really speak for the entire team. I know that they have some problems giving up Swift with all the nice features that we get. And I know other people have said that we haven't really seen a good cross-platform solution in action that is actually that equals success. And for me personally, everything that I've said so far has been pretty much, I think, a 3-year journey for me. I've learned shitloads. I've overcome the collection view terror that I had. And I'm not a strong believer that there's one size fits all. And for me, native is just the best fit at the moment. I'm comfortable and I can be productive in it. And I know that I'm keeping you, like I'm in between you and a bunch of beer. But I just want to show you some statistics to put things in a bit of context. So this is some statistics that I pulled from CocoaPods yesterday, or last night. And this is basically how many apps that we have touched by making open source. And I don't think that we would have done the same kind of investment if we did it for a cross-platform solution. It's basically CocoaPods that has opened up this huge door for us so that we can actually be active contributors. So if we didn't do this, if we didn't make the world a better place by contributing back, our apps touched would pretty much be 0, unless you count our apps. So to summarize, involve everyone in everything. No one wants to be left out. How you do that, that's up to you. We decided going with GitHub. It's been working out pretty good so far. Find a way to communicate synchronously. That's pretty much what I said. Go to conferences, get to know people. It's always nice. Be inspired but follow your own path. Like, if you do invest in stuff like React Native, know that your pain points are different than Facebook's, and pretty much you're abiding by their rules to some degree. So if you do decide to go that road, do some thorough investigation to know that it's a good investment at the end. When it comes to code and documentations, please don't build puzzles for other people to solve. Document, do proper naming, don't do every silly thing that we did. Have a clear separation of concerns. That's really going to help, especially if you have something that helps you along to enforce that kind of behavior. Find your own pain points. No one knows better what to solve than you do. Use patterns and practices where they make sense. Don't go all in on protocol extensions like we did. And also note that there are no silver bullets. And for humanity, know that it's okay to make mistakes. It's what we learn from them that actually counts. Don't be like me. Don't fear the unknown. And just because you don't know where a road leads, it doesn't mean that it's not worth taking. And just be a little bit nicer than you actually have to be. And of course, give credit where credit is due. And that was it. Thanks for listening. Any questions? No, didn't think so.
I'm just wondering how many libraries you maintain at Hyper.
I think if you look at our CocoaPods page, it's 24 that we have for Swift. Some of them they were made for specific use cases in customer projects. So they're pretty much more maintained by the community than us right now. So we're really working on a strategy to make it more feasible, like to actually add it in the description that this was designed for something else, and it's being used in a customer. Like, use it if you like, fork it if you want to make changes, but the direction of the project is tied into a customer application, for example. But I think it's about 10 or 15 frameworks, maybe.
Oh, okay.
And
is it only for Swift, or do you maintain for other platforms as well?
We do have some Ruby frameworks as well. They're not as active anymore. I think when we outstarred them on GitHub, they gave up hope of being rock stars again. So, sorry, Rubyists at Hyper. But it's like a culture that that the entire company has really embraced.
Yeah. Question?
How much time do you spend investing into these projects during the working hours versus like your free time?
It all depends. Like, it's in this specific framework, I've spent a lot of time. Adding Mac OS support is, of course, nothing that a customer should have to pay for. But the nice thing about having your customers on board is basically you're getting paid to do open source, which is kind of nice situation to be in. So you could pretty much, like, if you're fixing a bug in a framework, then you can get the customer to pay for it. And they also see the benefit in if it's open source, anyone can fix bugs for us as well. But when it comes down to how many, like where I spend most of my time, I think it all depends on how inspired I am, or if I have stuff to do on the frameworks. So it varies a lot. But we try to keep it within work hours so that we actually get paid for it. That's nicer. Alice?
Have you had any problems with clients, like saying this shouldn't be open source?
Yeah, so the question is if any clients have decided that it shouldn't be open source, a project.
We have had customers who, like, you have to be very clear in how you communicate this to customers. We're not really open sourcing their entire application, it's just the frameworks. But we have gone into discussions with customers that are like, okay, we want to own all the source code, and what happens if we want to build a framework based on something in their app, or that we see something that's reusable. And that kind of switches out how we tackle the project. Maybe there is nothing that we want to open source. Maybe this is super niche. Then we're fine with it. It's not like we have one process for every application, but we haven't really seen any. Like, customers are pretty much on board from the get-go when we thoroughly explain what it gives them.
How do you license the frameworks?
It's basically MIT licenses.
Okay.
I think we have that for all our frameworks.
Any other questions? Okay, then. Next thing on the party is just a party, so it's not that much more to think about. Just a few practical things. Food will be served on the top 2 floors, while the bar